This is chapter 6, homework 6, number 7. So here we're asked to use this theorem quoted in the directions to prove that f and g are inverses. So we'll start first by doing f of g of x. So I'm going to go ahead and take my g of x and plug it into the x's in my f of x. Okay, and so I'm going to have to FOIL this piece out. So you can refer back to the previous post and for question number 17 from the test review, I describe how I go ahead and FOIL something like that out. So I'm just going to do this now in my head, but if you need the extra explanation, I would refer to that previous post. And then over here, I'm going to distribute the 4 through. So really that I'm going to do this and then distribute a 2 through, because that just makes life a little bit simpler. And then here, I could distribute the 2 through, but really I'm just going to reduce again. And now I'm going to make a common denominator. So that common denominator here is 1, or is 2, 1, 1, 1. So the least common denominator would be 2. I'm going to have 4 plus 4 square root 18 minus 2x plus 18 minus 2x. And then common denominator of 2, that becomes a minus 8. Becomes minus 4 square root 18 minus 2x. That becomes a minus 14. And now that's all over 2. So if I combine some like terms, I have a 4 square root 18 minus 2x and a negative 4 square root 18 minus 2x. So those cancel, gives us 0. I have 4 and 18 is 22, and then a negative 8 and a negative 14, which is negative 22. So those are going to add to give me 0. That leaves me with negative 2x over 2, which is negative x, and I goofed a negative sign somewhere here apparently. Let's take a quick look. Where would it have been? Oh, well that's where it would be. It's 18 plus 2x, and I wrote minus throughout the whole problem. Not that it made a heck of a lot of difference other than this one spot, but there we go. And we just have to do the reverse direction, so g of f of x, same idea, but this time we're going to take our f of x and plug it into the x for g of x. This is probably a little bit easier, since there's no weird foiling that has to be done. Although we will have to do the long factoring. So there's that. I'll distribute the 2 through. And if I combine like terms, (4x squared plus 8x) and 18 and negative 14 is 4. And this I'm going to try to factor now, the polynomial underneath the radical. So notice I can take out a greatest common factor of 2, or I'm sorry, 4. And the square root of 4 I can take out. And x squared plus 2x plus 1 I can factor, multiplies to give me 1 and adds to give me 2, or 1 and 1. So it's x plus 1 times x plus 1, but I'm going to write that as x plus 1 squared. So the squared can cancel the square root. So we have here. And then I can reduce the 2, so negative 2 divided by negative 2 is just negative 1. And negative 2 divided by positive 2 is just 1. What did I do there? Is that not supposed to be a negative 2 there? No, it is. I have a negative sign issue going on again here somewhere. Because see, when I do this and I distribute that negative through, what is it? Where is my problem? Maybe I just goofed up this problem. When I made it, well, it shouldn't work one way and not the other. So there should be some issue going on here. Let's take another look here. So that all looks fine. Distributed through. Combine my like terms. Factored amount. I'm not sure what happened here, guys, but that's the gist of it.